this evening is not lucky. So it doesn't work, so I moved the file to the computer on the podium. So right now I'm ready. So before we start, if your name is the left-hand side, please let me know during the break time to assign one of the team. Right now, the group 4 and group 5, group 6. It's interesting. Supposed to be the 5. The 2 of the students may drop. I'm not sure. So anyway, we have 19 students, right? 19, and I assigned the 10 teams. So, there's a full. So 1, 2, 3, 4. Okay, so for group number 1, the DB, the manage, there's a manage, and then group number 2, the Joseph, this case here, and group number 3, Burma, right here, and the group number 7, the Serba. Okay, so 3 students are better. Why don't you find if your name is left hand side, find your team, then let me know, then you can start the project. Okay, that makes sense. Regarding to I used this one. I'm sorry, I got confused. So ArangoDB and NoseDB. How do I pronounce? Silla, and we have the Leak. Yes. So if your name is left hand side, why don't you let me know during the break time? Then we can finalize the team member. Okay. Then close this. Then regarding to the term project. So we have done the test 1 and test 2. So you propose and present the proposal, then the 10 database are selected. So using your selected database, you are going to perform the test 2. Test 2 mostly implementation. So in this implementation, you are going to first install the selected database. Then you need to find the data that you are going to model and upload. So it's not just one table, unlike the Hadoop, the file system. Instead, you are going to model and make several different table on your NoSQL database. So to do that, you can model the existing database. So then that is the modeling for your NoSQL database. So for example, if you select the graph database like the Neo4j, so you need to find the data that fit to your database, or you need to convert your data set into your selected the NoSQL database model. Then you need to create the database and upload the data. Okay, then implement some application, just like your database programming on your advanced database design. After you create the database on the DBMS, then you using your host program language like the Java or the C# or other Python, you need to implement the application. In this example, I'm not going to specify the type or the kind of application. So it can be anything. So it can be just client to server, the application to access your data, or it can be the benchmarking testing to how long it takes to select the data using NoSQL database versus others. Or it can be the data analysis if you want to implement something, the data analytics by adapting the library on the machine learning or the data mining technique is more than welcome. So please implement any type of application based on your NoSQL database. Sometimes it may be possible your selected database doesn't support fully the application API. even though they claim that they had the programming API, but when you are going to implement, you may realize that the selected database doesn't work, doesn't provide fully such an API. At that time, you can read my approval, then you can use the database that is selected by another your team member. Okay? So at the time, you can use another NoSQL database, but please contact me as soon as possible. If you realize that your database not feasible for the phase 3, then you can change the read my approval. So due date is November 2nd. So then, after you finish, we are going to have the poster and the paper. It's a presentation part, mostly presentation. So main part is a 3 part. One is the writing up. So you can prepare the writing up, the term paper with just like your proposal. You can continue to use the IEEE format, but this is my general comment for most of the team. So some of the students who already had the experience writing on such a technical paper, the format like the IEEE or ACM, the 2-column format, they did very well. But many of the students failed to use such the technical writing. So first, the technical writing should follow the very specific format. So for example, figure. So there are a lot of figures sometimes in the technical paper. Most of the paper has several figures. At the time, you need to specify the figure number 1, number 2, number 3, and so on. Then that figure should be mentioned in your body. If that is not mentioned in your writing, you don't have to put you don't have to use. Okay? Figure or table or photo, they are supporting material contents to support your writing, your idea. So it should be mentioned, referred somewhere in your body. Otherwise, just remove the figure. Okay? Then mostly, not mostly, it's a rule. The format, the caption of the figure is usually bottom up, like this. Okay? In case you have the several figures in one, so you can use the several one, A, B, and C, and something like that. Then after is the overview of the NoSQL database, including A is blah blah, comma B is blah blah, and the C is like that. You can explain the details of the caption of your using caption. You can explain the details of your figure. Unlike the figure, that in case you have table, the table is usually the top of the table, not bottom. Okay, so this is table 1. Also, this table should be mentioned in your body, in your writing. Otherwise, it's isolated, which means it's useless. So please think about such a thing. Then, if you are using equation, so equation usually, so for example, the sum is the summation I is 1 to the n, the a, the I, like this. Then you should have the equation number. So when this is the same thing, you should mention somewhere in your the equation number 1 shows the summation of blah blah blah. So always refer when you have such index or the numbering of the figure, table, or the equation should be mentioned. Sometimes you can use the footnote. Very rarely you can use the footnote. The footnote is like the one, like the superscript, or sometimes it's the 1 or sometimes A, depending on the format. Okay, then the bottom of the column, you can A or is the blah blah blah. Okay, Microsoft Word provides such the format. Or if you are using other editor like the LaTeX, so this is especially the PhD student should know how to use the LaTeX. It's a tagging the format. So definitely you need to know the LaTeX. They provide a way how to use the footnote. Okay. Then the reference. Many of the students fail to use the reference. If you use or refer the certain existing article or the published paper, published journal, or the published book, even nowadays the website is also should be referred. Otherwise, it's a plagiarism. Okay? So if you use existing notation, existing approach, existing exactly statement, so if you just copy and paste, always you should use the double quotation and the proper citation. Then the reference should follow the format. There are different types of format. Anyway, as long as you have consistency, it's fine. Then, depending on the format, it has a numbering, like the 1, 2, 3. Or sometimes it doesn't have the number at the time. When you cite this one, you need to use the number if there is the number. Otherwise, it should be the last name of the author. Okay, like the Lee. If multiple author, like this, then the 2018 published year, because it may be possible you refer the several paper published by the Lee. Okay, so you should use the citation and reference, the format. So that is the very basic one. Regarding to the writing, technical writing is really dry. It's not essay. It's not the biography. It's not the novel. It's not even the fiction. Okay? It's really dry, the writing, which means it should be like the most similar writing style of the technical writing is the mathematics textbook. Okay? Math textbook in the college level, even not in high school, they describe a lot. No, it's a mathematics book that you can use in the college level or graduate level. There's not much explanation or the introduction. It's just because in your writing, you are going to explain what you have researched in this project. Okay, this is just a fact. Okay, so you cannot say like this descriptive word, like my database is really the very nice, the interface. Okay, how much nice? The very is very subjective. So you cannot say I know you'd like to support your idea, you'd like to highlight the benefit, but you cannot use such the subjective word or the descriptive word. Instead, it's 70%, 71% better than the relational database query, like that. Then the people can admit, agree the idea or your result, something like that. Then I usually suggest the student to write, for those who write the technical paper first time, I usually suggest, have you ever used the flow chart? When you write the programming, right now it's not much used because of object-oriented concept. Object-oriented concept is different from the flow chart. But when I learned the programming language the first time, we have used the flow chart, like the start. There is a definition, and if processing, and the condition, and if yes or no, and A is here, and the different, then finally is the N, like that is. Like that, why don't you think about what you are going to write in this paper? The starting is the abstract is kind of summary. You don't have to write the abstract first. It can be the last after you finish all your writing. Introduction. Introduction usually very briefly. So you try to hook up the reader or the reviewer or the me. When I read the writing of or homework, I don't think all professors read word by word because it's not the English class. Okay, so first paragraph or first section introduction, it should be interesting. That also summarize what you are going to talk in this research. Okay, your NoSQL database. So, for example, the typical study, the format of the introduction is nowadays the internet is everywhere. Everybody uses the internet connected device. So that is interesting. Then the people may be interested in your idea. Then, however, there might be a problem. if there's no research without any problem, okay? Since there are the problem, we try to tackle, then to solve that problem. In this research, NoSQL database definitely would like to address something problem. So you can give the such a problem. Then my selected the Neo4j can address the problem of this one. Then this is a lot used in the market. For example, Facebook used the Neo4j and then read the citation. Then in this, then summarize what you are going to explain in the body. It's a really typical format of introduction in any type of technical writing or any research paper. And followed by second part, usually related work, or sometimes it's called in the PhD dissertation, it's a literature survey. Because the research, the writing is not the brand new one. It's based on something. So you can briefly summarize the type of NoSQL database. Okay, for example, in this kind of writing. So we have document database, key value database, and graph database, column-based database. Then in this paper, we try to focus on the Neo4j, for example. Then finally the main part. Usually, if this is a research paper, you can propose your methodology. But this is not the research paper, the experimental paper. Instead, you implement. So you can just in your body, main part, you can explain what you have done in this step, page 3. Page 3, you collect the data. For example, A, data set. B, installation. And C, the model. And D, the physical model, like the size of your table or how you can. Then the E is the implementation of the application. What is it? Or if you want, you can. If it's too detailed, you can separate by the different section, like the data and create the database and the application part. It's up to you. Then, if there are any result, like I'd like to compare the kind of benchmarking testing, this database with versus the relational database. You can do that. If you have any result, you can show the experimental result or the result. Most of the technical paper or the research paper has such a part. Then finally conclusion. Then add the the reference. Okay. So then first thing, do not copy and paste. I have seen a lot of students copy and paste. I know this is not your proposal. It's not like the research paper. You just collect a lot of information, but please write with your own word. Okay. I can easily find which one is copy and paste. Some of the students, even the format didn't change any format. Keep the original, the format of the Wikipedia or the numbering or the indentation is different, even font size. Some of the students still keep the different color font. Okay, so please use your own word. That is the really basic of writing. If you copy and paste without such a reference or the proper citation, it will be plagiarism. So it will not be definitely reviewed and problem. It's the same thing, ours. So don't copy and paste. Try to write. It's also your practice to write such a technical paper. Okay, that's the writing. Then based on your writing, then you can prepare the poster. Nowadays it's not easy to have the poster session. But I'd like to ask you to make the poster 2 by 3 size the poster, then encourage you guys to submit the faculty research day or the opportunity in spring semester. So always every semester, couple of students work more after my class, the NoSQL or big data or data mining, then they submit even the paper. So one of the students already got accepted from the international conference. So please submit this faculty research day at the poster, 2 by 3 feet, the poster with for the faculty research day, the template. Okay. Then the oral presentation, so 3 parts. So just like the oral presentation that you have done in your proposal, so we'd like to have the presentation. Right now we have the 10 team, so we may have the 5 to 10 minutes the presentation. That's pretty much enough. So even the international conference, they allow only the 15 minutes the presentation time, including question and answer. So I think the 10 minutes may be enough in this class. Any questions? The due date is November 23rd, is the middle of the Thanksgiving holiday. So I'd like to bring up the one earlier than this one at the November 18th or the 16th. I will make it a little bit earlier. Then we have roughly 1 month. So I think the 1 month you can do this kind of after the Thanksgiving. Then we can focusing on the presentation. And also we didn't, actually it's scheduled for today, is the schedule for the midterm exam. So instead, I'd like to have the one-time exam last day of the class. That will be, I think, the December 5th. Okay, December 5th we will have the exam. Okay, any questions? Okay, thank you. Then we will so the second part of the NoSQL database class, we will see several examples of the NoSQL database, including HBase, the Cassandra, the MongoDB. Then the GA, the Javier will prepare for another NoSQL database based on the GCP. So we will, in case if we do not have enough time, I'm going to take out the Cassandra. But otherwise we will see the Cassandra also. Okay, so today we will have the discussion about the HBase. Let's, for your reminder, let's go back to the Hadoop. The system Hadoop basically consists of the 3 parts. First, file system. It's a distributed file system, and to keep the big data. And we have programming framework, MapReduce, the framework. So these two are the core components of the Hadoop system. Then plus nowadays we have Yarn. Yarn is a resource manager, because since we are dealing with the cluster system, the multiple nodes, multiple server, some of them are very busy, sometimes idle, so we'd like to utilize or keep the load balancing using the Yarn. So old version without using the Yarn, so we have used just the daemon process, job tracker, task tracker, that they are not communicating each other. We have, even though we have the master node can check the mostly whether it's alive or not the balancing. So Yarn is in charge of such the resource monitoring and the managing. So these 3 other core components of the Hadoop. Then plus on top of that we have other Hadoop ecosystem, like the Pig, the Hive, Zookeeper, what else? Plum, Scoop, and many others. If you go to the Apache project foundation, so you can find a lot of Hadoop-based project. Then these are the kind of component on top of this one. This is required based on the business requirement. You can select some of the component, then you can build the Hadoop system for big data. Then you can do the programming by uploading the data to the Hadoop. But this one has several characteristics. Like one of the main characteristics of this files in the Hadoop HDFS is read only, which means write once and read many times, which means you cannot update, you cannot delete the data. Why? Is it really difficult to make the file system updatable or delete the data? It's not very difficult. You can make it by accessing the data, change it, but problem, it takes a time. So to get rid of any overhead to manage such a file, manipulate the file, we allow, it's just append, okay? Then write once, then read only. So that is the idea of characteristic of the Hadoop file system. That works when we deal with something such a big file. However, it is true, we need sometimes modify the data, sometimes delete the data, sometimes manipulate the data. So Hadoop file system through the MR, we cannot do such a thing. So that is kind of database management requirement. So most of the case, the Hadoop file system with the MR, or sometimes we can use the Spark for the data access, but that doesn't support the fully data management, the functionality. So to address that problem, so Hadoop, the project foundation, actually build a database that based on the HDFS, which is called the HBase, the database. So today we are going to see the HBase database. HBase is one of the most popular database that supports mostly the key value format, just like the HDFS only, but they are different. Basically, HBase has the functionality of the database to manage or the supporting index. Also, it's a consistency level. Not fully ACID level the consistency, but it's supported. So, for the key value data, and also it supports the documents database that is a column based. So nowadays we are using the HBase for the column based database. We will see such a data model today. So HBase is a database based on the Hadoop, but it's different from the HDFS. Okay, it's also just like any other the Hadoop ecosystem is based on the Apache Foundation, the Apache Software Foundation, the open source project. So which means you can use the free by downloading and install. You can install easily. Okay, then it's a column-based NoSQL database nowadays. Also, it supports inside the physical level, it supports the key value format, but in terms of database model, it's a column-based. So we will see more details of such a column-based NoSQL database model today. Okay, then this is the same benefit as the Hadoop. It's comparing to the relational database. So it has the distributed, also automatically scaled up when we have the very large database data. Okay, it's a short history. You don't have to worry about that. Nowadays it's a version the 2.1, but it's not recommended to use the 2 point. That's something the version in the market still the 1 point. But in our practice, we are going to use the 0 point. I forgot the version. I think the 0.20 or the 19 old version. But it's still the main part is not much changing. So you can learn the practice for the HBase. Actually, the Facebook used the HBase as a part of their system, but recently, really recently, at the I think the beginning of 2018, they actually throw away, take part the HBase as a part from their system. I don't know exactly why, but probably they had the new data structure. Okay, so as you can see, it's the same diagram as this one. We have the header core file system, and this is a MapReduce, but we have the HBase, which means from the MapReduce programming, you are able to access the data through the HBase, not directly. We have learned how to access and process the data in the HDFS from the MapReduce, but through the HBase, you are able to access the data. Benefit, you can use the index. And also, you can update or delete the data. Okay, so this is a benefit. But obviously, which one will be faster? Directly access the HDFS or through the directly access to the HDFS or through the HBase? This one is faster, okay, but not much flexibility. Okay, and on top of that, you can still use other Hadoop ecosystem. Somebody said the HBase is not like the database because basically the physical level of the HBase is this one. The data will be stored at the HDFS file system. This one, so think about, I had the read-only, the database here. So how can we implement this is the storage, like the storage warehouse. But this is always read-only. I cannot change the item. I cannot replace the item. I cannot take out the item. But how can I update the information? How can I manipulate such an item in this storage? We need to use separate. Okay? Or we can have something, the book. So this, the one is we no longer use. Even though we cannot take out this item, I just mark. This is no longer used, so delete it. Or if you update certain item is 1, but I cannot change it 1 by the 2. Instead, in my book, I mark in my note. So this one is no longer 1, it's 2. If somebody asks the value of this one, I can first check my note. Okay? So we can use separate the data structure where? Memory. So we will use the MEM store, which is called the MEM store, memory data structure, to manage such a manipulation of the data. What about the insert? If there is any new data, keep here. Okay? Keep here. However, if there are a lot of the change, modify, insert, delete, my notebook will be bigger and bigger. It's too big. At that time, if you have certain threshold or certain amount of the change data, we can replace the entire warehouse at that time. Okay? So you can get the idea. If you have a lot of update and insert and such a thing, HBase will be slowed down. But still, we are able to modify the data using memory structure. Then that memory structure will be separate the server. Okay? In the separate server, then that server access the HDFS file. Because anyway, it's a distributed file system. You don't have to access only the block in the local server. It can be separate. Then you can run the certain program which is called the region server. So we have another program that is called the region server. So region server is in charge of database functionality. That is the main part of the HBase. Eventually data will be stored where? It's the HDFS. That is the HBase database. But it is true, HBase is a very good fast record lookup due to the power of the HBase. Okay. However, it supports also record level insertion. How to insert? I will show you the architecture of that. We are going to manage the memory data structure for the update or insert or deleted data. Also, you can go update, but it's not in place. In place means what? Directly modify the data. Not in place means mostly the update the data is not in place. First, we are going to update memory, then synchronize to the secondary storage. For what? For efficiency. It's a default writing. So that is the reason when you remove the flash drive, you need to safely remove, because your update or your writing is on the memory first. So, it's 7 o'clock probably, right? Okay, so that is the HBase. So this is a comparison between HBase, the HBase. So this part you already know. The append only, but it's a random writing and bulk incremental, but it will be done in the separate the data structure, memory data structure. And the read is mostly a full table step, which means from A to Z. Read everything one by the UR partition, because the HDF is the cluster, the distributed file system. But it allows the random access because later I will show you the HBase has the primary key. Actually, file itself are sorted by the key. Okay, so we will see. However, data size is 100. Nowadays it's much bigger than that. It's all the data. But you can compare the size of the database between the HBase and HBase is much bigger, because we are going to use the additional separate data structure on the memory. It's limited by such a memory structure. What about the comparison between the HBase and the RDBMS? The RDBMS you already know. It's a row-oriented and the ACID and the SQL and so on. But considering such a RDBMS calculation, HBase is a column-based. The meaning of the column-based ID and name, job. What if I have the two jobs in the relational database? Job 1 or job 2? Or what if 3 jobs? Do I create another one? So because of that, multi-value another table for job, right? So this one has the foreign key. Then the one has the job 1, like the sequence or date, year, and the 2010 one, 2018, and job title, like that. You should normalize this one, relational database. And also, what if I do not have the PhD, but it has the MS and the PhD information? So we can keep and we can put the null. Null, even though this is null, null means there's no data. That doesn't mean it's a 0 byte. Okay? Actually, null has the meaning and the data structure. It occupies the space, and it will be compared using the is null and the is not null. Okay? So idea of the relational database is we are going to make the group. So all the tuple, all the rows are the same, the format, schema. Even though I do not have the PhD or MS, but we should put the null value to make the same the format. This is the IDBMS. On the other hand, why we did such a thing, normalization or the null value in the IDBMS? First, access the data very fast. Okay, if they have something redundant or if this is not the atomic value, we need to search again inside the column value. Okay, search again, and another search if nested. It will take a really time. Query optimizer will be confused, and also consistency will be hard. However, because of this characteristic, it's not flexible. Even though I do not have the PhD higher degree, I should create the same schema. Okay, so that is the main problem of the IDBMS. So how to address the column-based? This IDBMS, actually IDBMS, a relational model, is not the row-oriented database. It's both row and the column. We can consider the relation table as a group of attributes, as we discussed before. But we have a focus on the row-based approach. Each row, each tuple, each data are satisfied with the condition, predicate, where condition. So we access this data, we try to find very fast. It is true. Sometimes we can find, we try to find certain specific column. What if we have the millions of columns for one data? That may be possible. For example, sensor database. So I'd like to deploy millions of sensors to get the humidity, the temperature, humidity, and the pressure, and worldwide. Then they send the data every minute. So every minute, 1 million of columns. Sensor 1, sensor 2, sensor 3, times 10. So we try to find the column, region, or the location. The temperature is higher than 70. It's a column-based approach. So the column-based is a slightly different concept. In the column-based, we don't know. We have only ID. But for this ID, some of the people has the profile information. Some of them job information. Some of them has the experience. So it may have the several job or the entry-level job, and for the profile, it has an age and it has a name, but some of them may have another profile information, okay, like the nationality. Depending on the data, we can create a new column. This is a column, but this column is not fixed. It's not static. It may be changed depending on the data. So same thing for the job title. So depending on the ID, depending on the data, it can be added, it can be removed. Same thing for the experience. So these are called the column family. It's kind of group of the column. This is the column. Column will not be specified. Depending, it's dynamically you can add such the column. But instead, we are going to specify only the column family, type of column. So it's called the schema list. So there is no fixed schema of the data, unlike the relational database. The column-based database is more flexible. Think about the JSON file. Or if you are taking Python class, or if you know the Python has a dictionary. Dictionary. Does the dictionary has a fixed schema inside? No, you can add any the item inside. Inside the item, so you can add more. Okay? It's a list. It's not fixed schema. It's almost the same. It's very similar as a JSON file. So JSON file can be easily considered as the column-based database. Not only the document-based, so also considered as the column-based. So this, I will show you the example of the column-based one later. It was not implemented several years ago for the authentication and authorization. But nowadays, yes, the HBase provide such authentication and authorization. Also, regarding to the index, so actually the HBase has the only primary key index. The reason is that the data itself physically sorted the data. So HBase stores the data based on the row key. We will see the example. Actually, it's sorted. It's called similar as indexed table in relational database. So when we insert the data in the relational database, it will not be sorted. Just the heap at the last. But indexed table is, so we try to insert the data by following indexing structure. Similarly, the HBase actually, when we insert the data, it will be automatically sorted by the ID and added. Okay, it's a sorted data file. So that is the reason. First time it has only row key only. In other words, primary key only the database. But nowadays they provide secondary index. What is a secondary index? Non-primary index. Primary index is for the primary key. Secondary index is if you have the non-primary key column, like the name. Name can be the different order. So we try to make another secondary index based on the name. Then the pointer of this each data. This and this. So we can make the secondary index for the non-sorted column. So that is the secondary index. Nowadays, HBase support secondary index also. Okay. But it's very fast. It can support the millions level of the query at a second. Okay. Actually, this is not the primary index, but anyway, it's sorted. So we can consider such the index as the row key as the primary index, but actually it's not. Join operation. So if we actually fully implement the join, what is the join in relational database? We have one table, another table for each record of the left-hand side. Left-hand side is a driving table. Do you remember driving table? Driven table. For each record of a driving table, we try to find the tuple on the driving driven table. Okay? If that satisfies with the condition, join condition, then return. Save in the memory. Otherwise, next one. There are different types of matching. Nested loop, single loop join, and so on, hash join. So this is a join operation. What is the HBase? If we support such a fully implemented join operation, first the size is the problem. We have petabyte size data. We have petabyte size data. How many? So you overflow the memory to keep the temporary data. Second, really complicated. How many? The node. So when we upload the data, so like mostly had to use the distributed file system. It's a cluster, the 100. So my data is divided by 100. Then versus another 100. How many combination? 100 by 100. Then your network will be it's a full of the network. It's an overflow. So it will be more complex. So actually it's not really joined. If you remember the database model for the NoSQL database, we can application side the join. So when we select the data, we can compare this data with another smaller one. Okay? So that idea will be applied for the HBase. So HBase support the reasonably the join, but that is not the really join operation. Then we are able to access the data. It's called the scan. It's not select. The name is different. It's called the scan for the query and for the specific column and so on. So there are different types of the such as scan, the lookup. For the key, we can use the key of the data, and also we can wait all the data in the table or range. So we will see why the range is possible using the reason after we see the architecture. It is not fully automated or the something transaction management. It's not like the relational database ACID, but it's limited. Okay. There's no SQL HBase, but if you want to use the SQL style interface, you can get the another Hadoop component like the Hive queue. So you can use the Hive to access the HBase data like the SQL, but basically HBase itself does not support the SQL style interface. Instead, it provides API, the library. You will see the scan or the get or something like that. Then why we use HBase is a big table. When we use the big data, so actually it's from the Google, the big table, very similar. Okay. Also, it's open source. It's very close to the Hadoop, the Apache Foundation. It's a Hadoop, the platform. Okay. But it's not like the relational database. If you are focusing on the online transaction processing or operating database, the HBase is not a good choice. But it's it automatically scale up. So when you are dealing with really big data, HBase may be a solution. Also, it's a fault tolerance due to the power of the Hadoop system. Okay, so let's see the inside of the HBase. So if you scan is to select the table, HBase table. It's a table name, table 1, scan. It's like the select asterisk from table 1 in terms of a relational database. You will see like this one. So meaning is row is the key. You can see it. Row 1, 1, 0, 1, 1, 2, 2, 2, 3, ABC. Can you find any the pattern of this? It's a sorted. It's a sorted. Actually, 1, 1, 0, 1, 1, 2. So when you insert the data, physically it will be sorted. And it has a column family, CF1, and this one is a column family, like the group of the column, category of the column. Inside the column may be different based on for each data. Okay? We will see the more details of such a column family. So it's called the lexicographical the ordering, which means first number, then followed by the alphabetical order. We will use the HBase automatically. Then such a low key can be used for the primary key. It's not the same the data structure as the primary key index, very similar. So somebody just say it support the HBase support the primary key. But actually it's a low key ordered by the number and the alphabet. Okay. For the first column family, so when we create the table, we just define the column family. It's kind of the type, category of the column. Then when we insert the data, they specify the column. So it can be various of the column name. There's no fixed schema based on the column. Instead, you need to specify this AG belongs to profile column family. So when you create a table, you specify the column family only. This column family will be used for storage when you store the data. Okay, it will be one separate file. One column family will store the same storage. If you create the column family, 3 different files will be created and stored separately. Okay, so this is a column family. Then the column is the dynamically. Sometimes yes, sometimes it can be various. when we insert the data row, you can define the column. It can be many. It can be the millions of columns. It doesn't matter. It's not like that. So when you are using the NoSQL database, just like we have seen a lot, we need to forget about the concept of the relational database. Actually, relational database is really strict, the constraint. Okay, very specific, the data structure, and very narrow down. So sometimes it's bothering us to imagine the different types of the data structure. Okay, actually it's more the generic. The relational database is very specific, very detailed. It's too much strict. So sometimes such a column is called a qualifier, or because it confused column used in the relational data. Sometimes it's called a qualifier or the other name. So HBase may have the null because some of the data does not have the name. Some of the data does not have the age. That doesn't mean we are going to use the null. The null means in the HBase is really null. It's nothing, not exist. You don't have to keep any information. However, null in RDBMS actually take the storage to represent the meaning of the same format, same schema structure. So we put the null in case we do not have data. So that's the different thing. Then finally, the data. We have the atomic value of the value of the column. Similarly, the data in the header will be stored. The final stored data is called the shell. Okay. So we see there's such an example. I think we'd better see this one first. Okay. So based on that idea, each data has a row key. This is a unique. Okay, and ordered by this one. This is an example of to manage the website. Okay, like the com.cnn.www. Why is the opposite? Usually we are saying the www.cnn.com. Why com.cnn.www? Actually, this is the broadening company domain. Then narrow down to the CNN. Among the CNN web server, there is a www, like that. That is from the bigger to narrow. That is a usually way to access the data. However, think about the web, the domain name. Is there something? The specific file, domain name .com. It's the opposite way. So to store the search the data, we can use the opposite reverse way of the domain name. So this is a row key. Okay. Then the reason is that I'd like to retrieve all the row in the company domain. At the time, we can search this one. Range query will be easy in this way. Okay. Otherwise, if we use the order of the domain name like the www.cnn.com, .com may be here, .com may be here, .com may be here. You need to always do the full table scheme. So that is the idea of the row key here. And we define the column family. Column family is like the anchor. Okay? Anchor is cnn.com and the loop.ca, and when we access the data, where is the source of? That is called the anchor. So column family. Then another important thing of the HBase modeling is for example, I collect the cnn.com, the web page. Exactly same thing, but tomorrow. Then next day. There row key, column family, even the column name are the same, but it's a different version. So to keep the different version, in RDBMS, how can we address such a thing? We need to create another table for history or version table. Then the foreign key connect. Instead, in the HBase database, we are going to keep all the exactly same thing but different timestamp. So different version. Okay. One key may have the different version of the data. So that is the idea of the HBase. So this is another example. Okay, so for example, let's take a look at this one. This is the example of the employee. So whose name is Cutting, and the info and roles are the column family. So when we create this employee table, we can create the info column family, roles column family. That's it. Then when we insert the data for the cutting is the key. Then for the info, the column family, we are going to create the height and state, 2 columns in this case. For the role, ASF and the header, the 2 columns. One is ASF and header. What about the second, the row? It's the click on the row key. Info column family, it has a height and state. It's the same as the previous one. But for the role, it has a header role, hive role. So column names are totally different. Okay? When you insert, it can dynamically create a column name. Also, for the same column name, we have different version. It's a timestamp, 2010, 2011. So HBase support the version also. However, on the other hand, how can we access the data? When you access the data, you need to specify row key, column family, column name, and also version, timestamp. Then finally you can get the committer data like this when you access the data. Okay, so this is another view of the column-based database model. It's a row key, it's a key, it's sorted by the row key. Then we have a personal data, this is column family. This is another column family. Then it has the name and address, birth date and gender column. This one are not created when you create the table. Instead, when you insert the data, you need to specify. Okay, that is the column family and column. So let's go back. So this is the when you access the data, table name, row key, column family, column name, and timestamp finally 5. So this is actually the unique. It should be unique to access a specific column. Then the table level, it is stored at the sort map. We will see it later. And the row key and the list of the column and list of the value and list of the timestamp. So, okay. So that is the different. To understand the region and the region server, let me go a little bit forward. This one. So this is the Hadoop file system. This file system, for example, it is 1, 2, 3, 4, 5 different nodes, and the more if possible. This is the HDFS, Hadoop level. Then this part is the HBase. If you insert the HBase, the first component is the master-slave, the architecture. Because it's anyway the distributed system. So it's the master-slave. Then this master will be configured by the zookeeper. Zookeeper is one of the Hadoop component ecosystem. As name implies, what is the main role of zookeeper? Manage the zoo. Similarly, manage the number of instances and the component in the Hadoop system. Okay, So like the mostly configuration and the synchronize, not the data, synchronize their configuration. Okay, and load balancing. So client actually asked not the master node, instead the zookeeper. And the zookeeper knows which one answers which one. So then assign the client can connect to the region server. So region server has a number of regions. Each region has the, how can we actually update, delete, and replace the data using memory structure. So one server has such a memory structure. Then any changing data will be stored at here. Okay, this is one region. So this region is mapped to the node in the HDFS. But HDFS, what's the size of block size? 64 or 128. What about this one? This the file system has the same size? No. This is the 4. If we have the 64 megabytes by the block size here, if I update only one data, entire block will be changed. So it has a very small, like the relational database or the other, the online transaction processing block size is a several K. Okay, so this is a much smaller the block size, and this is called the region. So we have a number of region. That number of region is managed by the region server. So region server does not store the data. Instead, each region has the data. This region server is mapped to the HDFS file. Okay. Then there is another log data to keep the consistency and the durability of the data. Transaction management issue. Do you remember the write ahead log in the relational database? Write ahead log, WAF, write ahead log. Anyone who remember? Let me give the simple example. A is 1. So I'd like to update. The A is 2. What happened? First, find the A. Okay? And this block will be copied to the memory. Right? So always, even operating system use such a way, we cannot access directly update this one. Not in place, it's a memory. Then update. This is the original before image. This is the after image. Okay? Then, what is the end of transaction? Commit. When you commit, no longer you need the before image. So A is equal to 2. However, commit does not mean we update the storage. Okay? Still 1 and this is 2. Why? For efficiency. If we update the storage right away, it will take a time. So if we have a lot of update, it will be slow and slow. So we are going to update. Even though commit, update only memory. From time to time, we can synchronize. It's called deferred writing. Even operating system use same approach, deferred writing. Our flash drive always safely removed because of this one. Problem. Somebody unplugged the power. So this is gone. What happened? It's a 1 or 2. Should be 2, right? Because we commit. Right? So that is the problem. So we need to do what? Redo. Okay? This one should be 2. redo. How can we redo this update? So, yes. That is the log. That is write ahead log. When you commit, just before the commit, we have a log file. Then update A equal to 2, like this. We don't have to keep the before or after image, such a thing. Just the update A to 2. Then finally commit. So this one is in the reliable storage, hard disk drive. But this data is not. So even though this one is the gone, when we start up, we can check this one and this. This one's supposed to be 2, but it's still 1. So we need to redo operation. So then we can keep the data as a data constant to support the transaction, the management. So this is write ahead log. So exactly same thing. So we are going to keep the write ahead log because this is in the one server. This is a memory structure, so write ahead log. So this H log in the reliable storage in this server. Region server is a reliable storage. Not this one. This one is in the memory and their own storage also. Okay. So this is the region server. Then the number of region server will be managed by region. Number of region managed by the region server. Then one more thing is each column family will be managed by one region server. And not region server. Region. I always confuse. Region. This one is for the profile, and this one is for the job, and this one is for this one. And if we have the more and more data, new data is inserted, automatically split. It's automatic sharding. They split automatically. So first time it will start with one region and one region server. If you have more data, update it and insert it, change it, it will be split, more and more the region server will be, the region will be created. So this is the architecture of HBase. And going back to here, so region is the basically basic unit of the scalability and load balancing. That's stored the column family. So one column family. It starts from the one region, but it can be automatically the split if we have the more. The region server manages a number of regions. Okay. We will see the API level later. So it supports the write and delete the data. However, delete the data. How can we delete the data in this architecture? We cannot remove the data. Instead, just a mark. It's like a tungsten marker. What is a tungsten marker? Yeah. So it's a rest in peace. Just a mark. This data is deleted. So if somebody scans the data, we can skip just such a marked data. Okay? So that is the deleting. Actually, we do not, HBase do not delete the data. Instead, it mark as a delete. What if we have a lot of such a changes? We can synchronize that is called compactation. Compactation has the minor compactation is for the H file level, and the major compactation means all the files, which means we go to again here. If we have a lot of the changed one, so we can minor compaction means it's flushed out. We create the file. We cannot actually update or the random access to this file, but we can remove the block and recreate, like the compactation. Have you ever used the Windows 95 or the below? It it was recommended to disk compactation. Do you remember that? Files are separated. So from time to time, it's using the disk utility, you need to compact your file. Okay? How? Delete and create again. So that is the way. Same thing. So if we have a lot of changes here, HBase is on the separate. So why not use the recreate the file? So that is the compactation. When we have the more. Okay. So column family. So this is for example info column family. It's a one file and another the column family. Then if we have a lot of data in the one column family, it can be stored in different regions. So split. So by the region. So this is an example of the real view of the HBase file. Okay. This is a logical view for the data, and this is you can see the key is the sorted, and it has the profile and created follower name, created a column name, and there is a version, and these are the value. This is a real view of the physical view of the HBase, and this is the logical view of the HBase. So column family is the number of regions. We already talked. And it is matched to the blocks in the HBase, as we have seen the architecture. Then, when we scan the data in the HBase, as we have seen before, it's so fast. Then how can we make them fast? The problem of that, where is that? Here. When we access like the scan certain data, like this one, profile age is 10. First, they're using the, for example, key and this one. We don't know where data are stored. It's in here, or here, or here. Okay? Because in this level, we do not know. There is no index. So we need to actually search the index of this one, index of this one, index of this. It will take a time when we have the really large amount of data. So to address that problem, there is a Bloom filter algorithm to speed up. Bloom filter is not only for this HBase search, it's used a lot in many of the searching as a searching algorithm. Idea is a filtering. So let's think about we have the number of rooms. I'd like to find the student whose last name is Lee. Okay? It may be here, it may be here. So let's say it's here and here. So to do that, we need to search all of the room. So it will take a time. Why not? There are something filtered. So Lee may be room number 1 and room number 2. Maybe. It may be possible Lee is only here, but it's guaranteed at least that this room has the data for Lee, student for Lee. This is called the Bloom filter. Then how can we implement this one, filter? So actually it's a simple idea. So what is a hash function? Searching algorithm. It can be used for the searching algorithm a lot. Then what is basically hash?
Calculation of
Calculation. What is the output of a hash function?
a fixed size.
Hash key. It's a key. Okay? If the input, so A1, A2 are the same, hash of the A1 and A2 are the same. That's the idea. Then we can search the data. Then another benefit of hash is it can make very complicated data into simpler one. So one of the example of the hash function is modular. Okay. Modular by 5. Whatever the number input value, it will be 0, 1, 2, 3, 4. One of these. Then when you search the data, so instead of li, apply the hash. Okay? Then hash the li is the number 1. Okay? Then we can only search the number 1. It's only 20% of the data. It will be very fast by applying the hash function. Only one hash function, we can narrow down the search area by the 20%. That is the idea of hash. So output of the hash is the key, always the same. The problem, it's not the unique. For example, the James, hash of James may be same as the hash of Lee. It may be possible. Like the modular 5, 1 and the 6. Even though they are different, their hash key are the same. So it cannot guarantee the exact the data, but at least it can include the output of this one. You can search 0 or 1, but at least 0 or 1 it has. For example, we have the Bloom filter. It's a bit 0 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are initially set as the all 0. Okay? Then you can use a number of hash function. Let's say that we are going to use 2 hash function. Hash 1, hash 2. It's a different hash function. For the Li is in here. If hash 1 of Li is 0, okay, then change this is 1. Then hash of 2 Li is 3. Let's say that is the 3. So this one is 1. So when we search the Li, it's always the 0 and 3 will be the hash key. Then we can we can store the data, the number 0 and number 3. Then search only this one and this one. The problem is we are not going to insert only one Li. We may have number of elements. It's called the element, number of data. So, like we have the James. So James hash 1 is a 2. James hash the number 2 is a 9. So we have such a vector, the bit vector. Then when we search the data, we can check, apply the input like for example, we have a Smith. Smith is the 3 and the 6. If you check the 3 and 6, it's not in this, okay? Because it's not marked. However, if we search the James, so James is 1 and this is 1. So we can search the data. So this is a filtering using hash. We narrow down. The problem is actually there might be the pattern. Pattern, the output is 0, 2. 0 is 1. 2 is 1. So it may be possible it's a false positive. It's not existing, but output of hash Bloom filter is a positive. So try to access but fail. Then may be possible. It's not like the exact search in the relational database. But Bloom filter is kind of filtering, narrow down. But anyway, if there exists the data, it guaranteed to search, but fast. So that is the idea of the Bloom filter. Bloom filter can be used for many of the searching the algorithm. So HBase supports such a Bloom filter to speed up. Okay? And also the HBase support the compactation to synchronize between the HBase and the real file in case a lot of changes. So we already talked about a lot the times. Main part is a master. It's a master-slave architecture, and it has a region server. Then region server has a number of regions. That each region has the data of the HBase. Okay. Like this one. Zookeeper is working on the synchronizing the configuration around the number of the server. Okay. It's not only for Zookeeper, it's not only for the HBase. It can be used further to synchronize the configuration of the head ecosystem overall. Inside the storage, actually as I said, it is based on the low key. It's a sorted data. So their architecture is not like the indexing structure used in the relational database. Relational database, we use a B+3. What is the idea of a B+3? It's a balanced tree. So tree usually growing top to bottom. We have the root node, first row, and split. Unlike that, the B+3 is in case of full, we split and promote. So bottom to up approach to keep the balance of the number of level. So that is a B+3. So B+3 is good for what? It supports also range search. Okay, it guarantees the number of the node. So optimizer, query optimizer can use the level to determine how long it takes. The problem? What if data are deleted a lot? We need to merge. However, it's not easy. So when the node is empty, merging with the next one is not that simple. It's more complicated. So that is B+3. So we cannot use the B+3 to store this data. It's overhead. Instead, the log structure merge tree is, let's see this one. First, we have such a tree structure. So it has something the day 1 tree. Day 2 we have another tree combined. Then the merge. This is the first week. Day 3 is a Wednesday, merge is a day 3. Then eventually it will be first month. And this one. It's an append to the next sibling. It's not like the split and the promote. Instead, it's just append. It can be used for the log data. Log data is usually append. Okay? We are not going to delete the previous log data usually. Just a new log. So it can be the merge, and the promote by the It's like very similar as a heap style increasing append the data. So this is called the log structure, LSM3. So LSM3 actually using here. Okay. I'm going to skip the comparison between the B+3 and LSM3. Okay, then we have seen this one. For the storage, so we already seen the write ahead log. Going to skip this part. Compactation we already seen. So finally, we can use the interface API to create the table like the. So we can create the column family. So it's a column family. The new one column family like that. It's pretty much the same as the Java programming, but by adding the HBase, the API. So get the scan. Scan is a range search, so to get the data that's satisfied with that, the get is only one, so using the key. So to get the data, we need to specify table, row key, column family name, column name, and the version. Then finally, we can get the data, specific data. Okay. That is the get and the scan. So if you want to know the meaning of the scan and get, you can compare with the SQL style. So in this case, the dash satisfied with the cnnsi.com, it will return all the value. Put is insert. Okay, we can insert. At that time, we need to specify the column family name that exists, then but the column name. So that is a put. And the delete. The HBase does not support the join. However, you can do the application level, the join, to compare. You can do the MapReduce programming based on this HBase. That is the example of this one. Okay, let me start here. Then we are going to practice the HBase. You are going to create the table and get the data, and either insert the data and get the data, and so on. Okay, we will have the 10-minute break and resume by the 50.